Good evening. And welcome to this year's FR Scott. It really is a pleasure and an honor to have with us Dr. Isabelle Peretz. If you'll allow me a short introduction. Dr. Peretz completed her PhD at the Université de Bruxelles in Belgium, and today she's a full professor of psychology at the University of Montreal. She's a senior member of the CERNEC, the Centre de Recherche en Psychologie et Cognition. She is also the co-director of the International Laboratory for Brain, Music, and Sound. She holds a Casablanca chair in musical neuropsychology and cognition and a Canada Research Chair in musical neurocognition. Dr. Peretz is funded by all three of the great Canadian funding agencies. She's also funded by the extremely prestigious Human Frontier Science Program, the international agency. She's published well over 100 articles in very prestigious international journals, Neuropsychologia, the Annual Review of Psychology, Nature, to name but a few. It goes without saying that her work on the neuropsychology of music is internationally recognized. Bishop's University's Speaking Committee and the Department of Psychology are extremely proud to present this year's FR Scott Lecture, The Musical Brain, by Dr. Isabelle Peretz.
Represent my discipline, which is cognitive neuroscience of music, one of those prestigious series, the FR Scott series. And what Benoit hasn't told me that my accent is not fake. I have a very strong accent. So please bear with me. They're going to give many illustrations, mostly in French, but it's translated, and I'm sure you will get the flavor of it. So, first of all, for the musicians in the room, I'd like to say that I'm not really interested in music as arts, but really as in the function of what we call functional music. That is the kind of music that is intended for the majority, that is really appealing to everyone, and also participatory. It has little prestige in general, of course, it's not contemporary music or kind of artistic music, but it is closer to the foundations under which most people in most cultures enjoy and participate in their musical activities. So this is really the kind of music I'm interested in. And what I will defend or argue is that really music is in our nature, that I will take a biological perspective on music. And I would like just to remind you a few facts that we keep forgetting because, music is usually considered as an exquisite art and cultural product. While we keep forgetting that like speech, music is very old, and for some of us, it even preceded language. We don't have to put it, of course. It is universal. There is no society without music. It is also a human trait. There might be animal roots of musical behavior, but it will be very difficult to see an animal playing music. It is also acquired very early and spontaneously by the child without explicit tutoring, and I will show you a few examples. And also I'd like to remind you that like speech, it is auditory vocal and involves a lot of other abilities like perception, expression, memory, action, emotions, and everything you can think of. So, like music, like speech, music can be studied scientifically as a window to understand the functioning of the human brain, and also as a way to understand our human nature. So, what I will defend today, or at least give you example, glimpse of what we found. I mean, I will present also data from my own lab and trying to cover what has been found in other labs, but really focusing on what we have found in Montreal, of course. And the position I've taken for many years now is that really the capacity for acquiring musical abilities is innate, through specialized mechanisms, and is observed by dedicated neural networks. So really the idea is that music is considered as innate, that we are all born musical, and that really music is in our nature or in our genes, if you like. And most of the scientists in my field believe that on the contrary, that music is really a byproduct, that it is a kind of really the product of the fantastic machinery that we had between our two ears. But I will, of course, convince you, I will try to deny that it is really more biological than cultural. So the way I will approach this slide is just to present a few myths that you must share, I think. That is really resulting from a cultural approach of music. One is that, well, if you really work hard and you are properly trained and motivated, you will acquire musical abilities. And I will show you that this is true for the majority, except a few. And these few I found very interesting. The other kind of prejudice that you must have is that the majority cannot carry a tune, by lack of interest or by lack of practice. I will again illustrate to you tonight that it is wrong, that the majority is able to carry it. And finally, and I think that's what you are most interested in, there is the idea that music will make you smarter, the Mozart effect, and really the idea that music is at the service of other important faculties like language and intelligence. And I will illustrate again that this is wrong, that music is distinct from language and intelligence. But of course, to give you some idea of why it works. So let me focus first on what impressed me most in the condition of tone deafness or congenital amusia. And by way of introducing it, because I've been working on musical disorders for more than 20 years, the reasoning behind that is that really, when we focus on these disorders, it's just because complex systems like musical abilities and language abilities are better understood when they are malfunctioning than when they are functioning smoothly, normally. It seems really the medical approach that we are using in neuroscience. And what I will show you with this, and I will illustrate, for these cases can really illustrate how specific musical abilities can be, that is in giving rise to highly selective deficit, and that it is a result of a brain anomaly. It has limited plasticity, and it is also genetically determined. So this is my point, of course. So the half of my talk will be on that condition, and then I will turn to the other aspects. And of course, if you adhere to the opposite view, you will think that really problems like musical problems cannot occur in isolation. They must be associated to other disorders, because music is not really a distinct faculty. And also that training will help, and that it is really a question of experience and training. And of course, I will illustrate that is again a myth. So let me just characterize what we call congenital amusia or tone deafness. They are amusic from birth, and these are really unexpected failure to develop normal musical capacity despite normal intelligence and normal language. They are unaware of how they sing, and we have several examples. They fail to recognize popular tunes without the help of the lyrics. I will illustrate that too. They have great difficulty learning to play a musical instrument. I will not show you this. They just complain about it. And they have no other educational deficiencies. This is very important. And it is really similar to other developmental disorders like dyslexia, specific language impairments, or also recently congenital prosopagnosia, prosopagnosia. That is the problem to recognize faces. I mean, most people can recognize faces, except a few. And apparently congenital amusia occur with a population of 24% of the population. This has to be revised now because it's an old study, but it's relatively rare. But depending on your formula, it can be, interesting enough to study because dyslexia, for example, occurs in 4 to 7% of the population. So a few well-known cases. Just to reassure the few of you who might be listening. Chick is a well-known case. I mean, it is recorded and documented. And as, the oldest one of you know, he was a very well-known revolutionary figure. And also he was well-educated. He was a physician. But he was unable to recognize his own anthem. And this is the kind of illustration of what I want to illustrate tonight, is that the person is really highly functioning, doing spectacular things, very important things, and yet the level of achievement in particular areas like music does not match with what the person has succeeded to perform in the rest of the functions. And it's not only leftist. I have a conservative one, and it's Milton Friedman, who got a Nobel Prize in Economy, and who wrote at the end of his career, because this is something that you don't acknowledge easily, that you have problem with music. And he writes, and he had a violin lesson, the correct education. I remain a musical illiterate who gets no pleasure from music, whether classical or popular. Last but not least, especially in psychology, Freud. And he described himself as quite unmusical and almost incapable of obtaining any pleasure from music. And I should remind you that he was living in Vienna at the time, which was the capital of music. So how do we find those people? I mean, those are, well-known figures, and they really write that at the end of their career. How do we find them? Well, we just put advertisements. And we do have people who dare to come to the lab, not many. And this is one description. And this is a typical story. And please, for those of you who understand French, also pay attention to the prosody. For the other ones, it's easy. Just pay attention to the prosody. And I can anticipate. The prosody is perfect.
Avant, oui, parce que j'avais subi une grosse défaite. Alors, j'étais pensionnaire et la religieuse cherchait des membres pour la conférence. Puis moi, naïve, je me suis présenter, puis elle a dit à la viens, je chante pas, je sais pas chanter, je chante ça. Parce qu'on m'en avait dit. À ce moment-là, vous êtes entraîné à l'histoire. Ah, c'est quoi, hein? Fait que là, je m'en vais là, puis on chante ensemble. Puis là, des bouts, je fais juste des lèvres, mais puis bon. Puis à un moment donné, la religieuse fait des auditions. Chacune doit passer à son bureau, puis chanter un petit morceau, un petit peu. Mais elle savait que j'étais réticente quand même. Elle savait que probablement qu'elle avait noté que je ne chantais pas toujours. Fait qu'elle me demande de chanter au Canada. Catastrophe! Je ne sais pas quelle ligne que j'ai chantée. C'est la ligne où je vais au Canada. Mais la première phrase, elle m'a arrêtée, elle dit « Vous voulez lire de moi? » Out! C'était mon expérience. J'étais un peu frustrée parce que je n'avais même pas compris que peut-être même un bon chanteur n'aurait pas pu arriver à ça. La difficulté que j'avais à mimer ça, même un bon chanteur probablement n'aurait pas pu à me passer le Canada.
And now, okay, a few examples. I don't know if you know the Quebec way of singing Happy Birthday. It is Jean Dupéry, the Gilles. So, but I will give you two examples later on. But I mean, you don't need to know the tune. They are singing the same one, all right? They are in music, of course. So the first one.
Mon cher Michel, c'est à ton tour de laisser parler d'amour. Mon cher Michel, c'est à ton tour de laisser parler d'amour.
I know my favorite one because he's always singing on the same tune, whatever lyrics he has.
Mon cher Michel, c'est à ton tour de te laisser parler d'amour.
So obviously he sings, but it's not the right thing. And I mean, the way we show the dissociation between language and music, it's really an efficient way to use songs like this one. So Albert, you just saw him, is really a typical case of conventional music. I'd just like to tell you that he has a very high IQ, so intellectual quotient of 117, and he had 16 years of education, so he's highly educated, he has everything but music. And the kind of game we are playing, it's not really a game, we just collect data, of course. I'm just illustrating this with one example, but we do repeat that many times in the lab. And we just ask the person to name the song. So we ask to name the song, you have the answer below, and we present the lyrics. We do not contain the title, of course, like here.
Allons, enfants de la nuit, le jour de gloire de
He has it right away. Okay, now see what he does with the tune. The title. Okay, good. And see what you do. You can.
Faster, dann Feuer.
And he proposed a choice, and he chose the wrong one. So, no idea. So that's really a convenient way for us to document the dissociation, because we know they learn the songs because they know the lyrics, but they didn't keep in the memory trace of the tune. So this is a very different situation between music and language. So what do we do with that? Well, what we want to do is just to explain it. I mean, how can we account for this kind of behavior deficit? So you have the behavior here, and there are different levels of causation here. Of course, you start with the gene and the environment, and they interact to influence how the brain develops. And develops, so it's really a question of connectivity, of neuronal migration in the brain, which will, I mean, these processes will support for the functions we are interested in, and what we call cognition. But the way we work in cognitive neuroscience, we work in the reverse direction. We go from behavior to the genes, if possible. That's what I'm going to do with you now. So you have seen a few behavioral markers, but there are others. So first, we'd like to specify the behavior really symptom that is the most revealing about the cognitive functions. So let's go there. So we do use battery of evaluation. I won't go into the details here, just to let you know that we do have a battery of tests that allow us to know, to have an idea of how the person is perceiving and memorizing music. We use a familiar tune like this one. And we introduce differences like, is it too loud? Sorry. Yeah, I know. And we can introduce a different pitch control like this. And the task is saying different. They have to say it's different in this case. Or we introduce a rhythmic difference like this. And we have norms. So we can situate the person relative to the norm. So when the performance is 2 standard deviations below the mean, we judge that the person is probably in music. And in fact, on the basis of this kind of test, we have observed that here you have all the music cases. We have set them in 2 or 3 Hamilton square, and these are normals. And on this dimension, you have the performance of the melodic test, and on this axis, you have the performance of the rhythmic test. And as you can see, all of them are impaired on the melodic condition, while only about half of them have a problem on the rhythmic aspect. So really, the problem on the melodic dimension is the core deficit in this condition. And of course, we had the hypothesis that it must be related to the way pitch information is encoded or mapped onto musical scales or on keys. Because it is music specific, because it is automatic, mandatory, and for those of you who are not musicians, you are doing it. I'm going to show it in a moment what it means, and it is present in infancy. So let me illustrate first with Albert again, my favorite case, I told you. So we are presenting, again, it's only one, it's just because we are showing this for TV shows, so we have only one example. And we ask the person to judge if it's rather pleasant or unpleasant, and we are playing with dissonance. That is, we are really shifting the melody by 1 semitone relative to the accompaniment. Very simple. And in principle, normal individuals will prefer the consonant version to the dissonant one, clearly, on a kind of scale that I feel from pleasant to unpleasant. Let's see what Albert is doing. Oh, I'm sorry. Three. And let's see now what the infant does, because we know it is I mean, you are born with the capacity to prefer consonant over dissonance, but I love this video, so please enjoy it. So, you will, I mean, what is considered as really a measure of preference here is the time the baby is looking at one of the speakers that is delivering the music, a particular kind of stimulus, in this case. You will figure that out by yourself. It's quite clear. And the mother is, of course, wearing headphones with a different kind of music, not to influence the baby. Ready to But I think you got the point. Okay. So, I go on. Sorry. Another way to document the fact that they have difficulties to encode pitch in a musical way, in kind of musical phonology, what we call it, is to ask them to decide if there was a wrong note in the melody. So to give you an example in a familiar one. Okay, and now what is a little more subtle is an unfamiliar melody. diagnostic. As you can see, each dot there represents one subject. And as you can see, there is no overlap between concourse and music. This is really a test that taps into that problem. So it does confirm our idea that it is really at that level that there is a problem. I mean, musical is a complex system. As you can see, there are many different modules and systems that are involved into the understanding of music, but we really believe that the problem is related to pitch. It's not so clear. Sorry. And so, where we are now, that I showed you the behavior, the idea that it is really the cognitive problem at the level of mapping pitching to tonal knowledge, or knowing the kind of scales that are used in our system that is impaired or deficient in these cases. So we are to the cognitive level. So let's go to the brain. So what we have done, I mean, I'm just summarizing, of course. I'm just showing one slide while I could talk for an hour on each of these problems, of course. We did analyze the morphometry of their brain. That is, it was, of course, we had images, MRI images of their brain as a group. Because when you see the brain, of course, it's normal. I mean, there is no gross anomaly. It's just on averaging the brain of the Amusics and compare them to the brains of normal control that we can highlight differences. And we did find differences. And we found differences in the right interior frontal gyrus. In fact, we found first that there was less white matter, which is really a question of connectivity in the brain. And then later on, now, in fact, recently, we found also that there was more neurons, that the cortical thickness was higher in the brain of the Amusics in both this same region and the auditory cortex. So the idea is really it's a question of communication in the right hemisphere-based network between the temporal lobe and the frontal area that is deficient. To give you an idea that we did find brain anomalies that are very subtle, but that you can find with the new techniques that are available. So I'm now at the level of neurobiology, and I'm turning to genes. So the first question we need to ask is it running in the family? That is it hereditary? This is a very long and we tested them via internet with the kind of test I was presented to you. In one series, there was a time delay instead of a time asynchrony, that is a time gap. And in another series of melody, there was for this kind of wrong note that were out of key. And what we found is that on the time dimension, I mean, I don't remember one. Let's see it here. Oh, okay. I don't have it on my screen, so it doesn't help. So what we have here is that they are performing similarly. Concords, relatives are the siblings, brothers and sisters. And the Amusics in blue. One of the pictures I mentioned are predicted, and the concords are, of course, performing very high, and the Amusics are impaired. That was what is a very interesting group with this one, the siblings. And we use as a criteria that, again, 2 standard deviations below the mean means that they are affected. And what we found is that about half of them are affected. That is 43% of the siblings here are similarly affected. So yes, it seems to be hereditary. It's not a simple kind of transmission, but it is very similar to what has been observed for spoken language disorders and for other traits like absolute pitch. And also, it is also consistent with a twin study that was reported in Science in 2001, so a few years ago, showing that this kind of test, exactly the same kind of test, to detect a wrong note in a melody, was related to genes by doing a twin study, that is the monozygotic traits have a higher correlation between performance, between the two twins. The performance is highly correlated, very similar, compared to oh no, I don't have it. Thank you. twins who share only half of their genes between them. Sorry about that. So the idea is really that, you know, of course, environment is playing a role, and we'd like to identify, of course, those aspects, because we cannot change the genes, but we can change the environment. But in summary, the point I want to make is really that tone deafness or congenital amusia is hereditary, and that irritability appears speech-based, but interference or competition here. And musical pitch encoding, of course, appears essential to develop normal musical capacity. And of course, what is really exciting now is that we are starting to search for the responsible genes by doing DNA analysis. So that was really for the main core of my presentation. So the idea really that, yes, the majority can acquire musical abilities. As I said, we are all born musical, except these few, these 4% of the population that will never acquire. I mean, never, that's a big word. I mean, when they are adults, it's too late. When we are working with children, that might be possible. And we do. We are trying that now. So now let's turn to the other myth, and that one you may appreciate a little more. The idea that really the majority cannot carry it through. And curiously, when you want to check that in the literature, you find nothing, because it has never been evaluated. Everybody believes that, yeah, I'm just listening to the people around and they just think, well, not sure. So we decided we would study that.
Mon cher Michel, c'est à ton tour de te laisser parler d'amour. Mon cher Michel, c'est à ton tour de te laisser parler d'amour.
She's not singing, she's speaking, and she doesn't know it, she's unaware. She really thinks that she's singing. She has the words, she has not the music. But you can have someone else, like this case, who has a lesion in the right hemisphere, who will sing the same song, but in a different way. But she will be singing.
Mon cher Michel, c'est à ton tour
And it is slow.
de te laisser parler d'amour.
Okay, I stop there because it's quite long. It's not all. You can find, I mean, you think it's really, I mean, it is the result, the consequence of the brain damage, for sure. These people were singing correctly, accurately before, and we have proof of that. Now it can occur in musicians too. And I will illustrate with one person who was working in our lab and was not aware that he was singing out of tune. He had a master's degree in music education, was playing flute, and he began training at the age of 11. And what is really spectacular is that he has actual pitch, the ability to name a pitch without any reference. And this is how we sing, I think it is Happy Birthday.
Bonne fête à toi, bonne fête, bonne fête, bonne fête à toi.
Now you sing that, the thing that maybe he can. Well, when you have the musical scope, you can.
Do, do, ré, do, fa, mi, do, ré, do, sol, fa, do, la, fa, mi, ré, si, la, fa, sol, fa.
Okay, again, I could spend an hour to explain everything here. I just want to intrigue you, but my point here is not the question of training, right? It has the training. So, and just for the pleasure, mon cher Michel, again.
Mon cher Michel, c'est à ton tour de te laisser parler d'amour. Mon cher Michel, c'est à ton tour de te laisser parler d'amour.
He's one of the few who is making this kind
Mon
of
cher
control.
Michel.
gone through error. So you see, that was my point for the idea that really, it's not really a question of training, and that you can find really a dissociation between music and language, including in singing, which is really a fantastic way to study these two big systems. So where I was is here, but the idea that really music is not at the surface of language. I mean, you can see that these two are dissociated. They probably can combine and interact and be at the surface of each other, but not one at the surface of the other. Now, I'll turn to music makes you smart. So let me just illustrate why there is doubt that music is. I mean, if you are playing music, making music, that it will make you smarter. In a sense it does, but not directly. So let me illustrate that with another condition that is coming from the clinical neurology or psychology, to the condition of autism. You must have seen that these cases who are really kind of musical savants, but who are really retarded in terms of intellectual functioning and social functioning. And this is one case. So she was filmed for another TV series, and what you will see is a very short snapshot. I mean, you will see one of my students playing, it's a 2 pages composition. She has never heard that before. It was really composed for the purpose of the show. And but it is in the kind of music we know she likes. So it's a kind of film genre, if you like. And she will come later, and from memory, she will play it afterwards. Except just a few bars, of course, but it's enough. Oops. And I know. So the point I want to make is that she's not performing like a tape recorder. She got the gist of it. And she just improvising with the gist of what was presented. And that's really important because it's showing us that she knows the rules, she has the musical knowledge, that she has the skills. And yet she has an IQ of 70 and she is not autonomous. I mean, she's still living with her parents. She's 21 at the time of filming. So it's again to illustrate, you know, the difference between music that can be spared, or you can, in this case, of course, be spared, while the rest is quite deficient. Now the infamous Mozart effect. I know it's just because I always have questions about that, and I did some work on it. So what is it? Well, students listen to this music. Complete this kind of task. So they are showed, you know, this kind of paper folding with cuts one corner, and students had to pick the ones that correspond to it. Do you have it? Anyone? No. All right. I think it's D, but I'm not sure. I need 10 minutes. And what they showed is that indeed, after listening to Mozart, the IQ was higher for the musical condition compared to a condition when they had music relaxation music or science. That's what was reported in Nature, and it had, you know, a huge impact. I mean, the Mozart music was given to babies in California for free. I mean, there was a big, but they got a lot of money too to do this kind of research. So it's very serious for us as an ethic. So after a while, all of us need to work on that. But I won't tell you the results. But what is really the consensus is that whenever you have an ethic, that is, it does improve cognitive performance. It's not only this kind of IQ thing. It can be any kind of task, cognitive task. It's because it is mediated by emotions. That is, of course, it's much more pleasant to listen to this kind of music than to stay in silence for 10 minutes and waiting for a text. So this is exactly the kind of explanation of the Mozart effect. It's the musical effect, not because it has a direct impact on your brain, but it is mediated by the emotions. It does higher arousal and also more motivation. And they did that, in fact, at the BBC, what they called the Mirror effect. So they presented to adolescents this kind of music. So really, that's the last point I wanted to make, that yes, music is the language of emotions. And I won't be able to present all the results that have been collected recently on music and emotions. I'd just like to illustrate it with the children, with a paper we did and to remind you that really they are exposed to this kind of music very early on. It's just to show you a few clips of Walt Disney. He was a master. I mean, they are masters in manipulating emotions in children. So this is from 19? Okay. So you understand the kind of emotion it is evoking, and this is the opposite, of course. And so on. And I mean, you can find tons of examples in Walt Disney films. So, in fact, we were interested to know how early these children could use what we call the tempo and the mode, because the first clip was really major and fast, while the second one is minor and slow, and this really are characteristics that we use in our music to distinguish happy from sad music. So we presented this kind of music, and these are really classical kind of music. I mean, we made that mistake. We should have used Walt Disney, of course, but it worked. So, and what I want to illustrate is just how easy it is to show that children can use this kind of cues of them, know the structure of the surrounding music, of the system of music that is around them, by manipulating very certain aspects. So we played something like this. It's not exactly the original because it was computerized, because we wanted to manipulate the aspects, the structural aspects, and that's again a study we did together. I'm pleased with the efforts. And after that, we just ask them, is it rather happy or sad? Both they may choose the happy place for that, and you can see that even 5 years old can do that easily. And then in another condition, we just changed the tempo. So we took a kind of medium tempo, like this. And again, they could all above chants use in church that it is still happy, but they were hesitating. So it was less happy than the original music. And the same for the mode, except at 5 years old. They didn't really use the mode as efficiently as the 6 years old. And this is the mode change. So in this one it is a little more subtle, but it is minor, but at the same tempo, of course. And now when you have both, they no longer find it happy. I mean, they really are in between. And they are like adults. So we do use the same structural aspect in music as adults. And that's really the point I wanted to make. But there are really many, many studies on this aspect that are fascinating, but I couldn't include everything in my talk. So to conclude, what I tried to convince you is that there is evidence that the musical capacity rests on distinct mechanisms, at least as far as language is concerned, and not only in perception but in production. And I really emphasize the production aspect tonight. That it develops spontaneously in everybody, in fact, except the minority. And it's not a short process of training, you could see. And it is associated with special neural networks. I didn't really emphasize this aspect, but this is the way to understand when you can see that after a lesion, you can dissociate the two. It must be really separate between music and language. And it triggers strong emotions. I just showed emotions and maybe not the strong ones, but it's easy to document. So really, with all these features, I mean, it's very hard to argue that music is a simple cultural project. So this is what I wanted to present tonight. So thank you for your attention. I love questions, so don't let me. Oh, yeah, sure.
I have a comment on the slide where you actually supported for my own criticism about the example when you say everyone can play a simple tune, and then you showed us an example of someone who you said had a lot of mistakes, and to me it was just that he picked a register that was too low for him and he couldn't reach the low notes.
That's true. That's a good point. We do now confirm for that aspect, that it is really to help them to change
to choose a register that good for their voices.
That's true, it was too low. But what is funny, that it seemed to be the case of the people who have a problem, but this was not really a big problem, because...
No, because all the other notes were fine, it's just it couldn't reach that note.
Yeah, so maybe. Yeah. But it was too low. And the other case. Yes.
It seems that pleasure is at the center of all your theories. So for the Amusia, is it that all the music is neutral, or it's all equally arousing, or what?
That's a very good question. In fact, it varies from one case to another. For some, it is unbearable. I mean, you can't. And it's very difficult for us to test them. And I think it's really a question of time. There is something in the musical sound that is problematic. But for most of them, it's like, you know, if they are going to a show, they will appreciate the movement, the social environment, the action of scene. But if you ask them, really, do you listen to a CD intentionally when you are alone, then most of them will say no, never. And when they do, it's because there are lyrics in the songs. So, and when you test them formally, they cannot, as you could see, I mean, they cannot hear the dissonance. So they said, yeah, that's fine. I mean, they really don't have a problem. And for most of them, it's like listening to a language, a foreign language. I mean, it can be pleasant, of course, even if you don't understand it, just because for the other non-verbal aspects.
Because there's a distinction between pitch and rhythm. So people who are on music but have a good sense of pitch would probably prefer percussive music.
Yeah, that's what we thought, but it doesn't seem to be the case. We are starting to study all the rhythmic behavior like dancing, tapping. I mean, half of them are okay in terms of tapping, but half of them are really impaired. So really what I think that, you know, it's in development. If you don't have the pitch, you might not really develop a good sense of rhythm as well. But we need to really study that into more details. And they don't dance either.
Don't dance?
No. But we're going to make it. Yeah, I'm ignoring the right side, I'm sorry. I started on the left side, so maybe I should have at least one here.
I just wondering whether there's, whether you can make a complete distinction between something that's genetic and something that's cultural. And I've got two questions. One has to do with the kind of scales that you use, so that we hear things in tune that are in a Western scale, but someone that learns a different scale would hear something else in tune. And that's got to be cultural to a certain degree. And the other is that the children learning major and minor, and is that not also perhaps something that you learn just by the music that's around you, and happy music tends to be in nature, and sad music tends to be in minor, and how can you know
Sure.
what the same way for someone in China?
No, sure. I mean, I was simplifying here, but as I said, it's really environment and genes that are really guiding and determining how the brain will be organized, and of course it will have an impact on the functions, for sure. I mean, and so it depends on the kind of system to which you have been exposed. But here I'm really talking about the musical system to which they have been exposed as a child, and you of course acquire that system if you are well equipped. So the question is always, of course, if there is a genetic anomaly, then you may have a problem to acquire this kind of skills or tonal knowledge. And if it were in another culture, like in China, then they may have problems to acquire their own system. And of course, we start here, and we have to do this kind of cross-cultural studies to validate this thing. And the other point is, that the reason I was presenting what he said first is to show you that indeed they are exposed to this kind of music very early on. So it's very difficult to argue that it is something that has been acquired, or, I mean, of course it cannot be determined as such. I mean, what is determined by genes are not really our musical system per se. I mean, what is determined the way our brain is organized, which in turn can, tune or at least shape the kind of function that are compatible with the brain structure. So it's a big jump from the genes to the function of the nervous system.
Thank you.
Yes.
Along the same thread, it's often said like with certain cultures, I guess mainly African cultures, Yaban cultures, a very rhythmic culture. Is there anything empirical to suggest that certain peoples are either biologically or psychologically more conducive to music, or?
Good point. I don't know. I mean, I don't think there is any evidence. I mean, I would know if there was any evidence. If it's possible, I believe it can be possible. Why not? That the African people would be more rhythmical is clear. I mean, it's so obvious. There must be a reason. But it's hard, I mean, to distinguish between genes and the environment. But it would be a nice question to ask. Next to it, we have to definitely first in our own person. Yeah.
Have you done any tests in your lab related to music and memory? Music help you remember things? Does it not have an effect on memory?
Yeah, I'm afraid to say it doesn't. We have studied that. I didn't present anything about that, but what we did is that we did present songs, either the lyrics were sung, or the lyrics were spoken, or the lyrics were spoken and you had the music in the background, because sometimes it can be confused. So it was really well controlled, and when you do that, I mean, they remember as much when they are speaking, and even better. So it's really a dual task. I mean, you have to remember the tune, and you have to remember the lyrics. So you have to remember two things, and it does interfere on performance. However, the trick is to use a tune that you know well. You know, like Jean or Big Birthday, and put lyrics on it. And then you might have an advantage, because you have two cues to help you remember, but you don't have to learn to perform. See the point? Okay, or in the middle.
When a woman is pregnant, does the fact that she listens to music or performs music, does it have any consequence on the musicality or non-musicality of the child?
That's a big question. What we know now is that, I mean, and still, it's not really well documented, that the baby will recognize the music that was presented when it was a fetus. But for the voice of the mother, for example, we know that there is some memory for the voice of the mother, for example, you know, by the reaction. So it's starting, these kind of studies are starting, but to go as far as expression, we can for the moment. But can imagine. Yes.
Rez, thank you so much for an extremely informative talk. The data is just wonderful. This great, and the double dissociation stuff with the aphasia and the pitch is just right there. What I'm going to ask is, of course, I believe it's hardwired. It's in there. And it's evolutionary. Have any of you or your colleagues ever pondered what sort of adaptive advantage having this would bring?
Well, I wish I could answer that, but
I can't answer. I'm thinking, you know, Pinger and a lot of the other ones said it's just a byproduct, and I know it's not a byproduct.
Rock star.
I just wondered if any of your colleagues have thrown out some hypotheses.
Of course, there are hypotheses. There are two. And the first one was put forward by Darwin himself. And for him, it was really sexual attraction. That music was a kind of, you know, attractive. And it is true. I think it is true. I mean, yeah, I think it's true. But it has never been documented. I mean, it's easy. So there is no evidence. The other hypothesis, which makes sense too, is that it has a group cohesive force. I mean, you don't feel alone when you sing or dance with someone else or with other people. You feel like one. And this kind of social force is very important, of course, in the ancestral times. But again, we don't have any evidence. So these are the two main hypotheses for the adaptive role of music. And for some, it really preceded language because of these two very important aspects. But, you know, it's pure speculation at this point. Yes?
I had two things, actually. The first one, I'll ask the second one first because it relates to something you said over there about African people being more rhythmic than melodic, and in the Western and other parts of the world were more melodic than rhythmic. But if you look at people of African descent who live in melodic parts of the world, they can be very melodic.
Sure.
So I think that I don't see it, that there would really be any difference between geographic adaptations. It just happens to be what this culture does as opposed to what another culture, because we obviously take the people out of the culture and they adapt to the new culture. But
sure.
As an observation.
Sure, but I mean, I don't think the question was really at the level of the cultural adaptation. I mean, it depends on the age, and you see, it depends also, it's like the accent in languages, I mean, it's like everything else. If you acquire it too late, it's too late. Okay, but, and of course, we learn the music of your culture. But the point was maybe, you know, because they have been more rhythmic over generations and generations, for whatever reason, it doesn't have to be geographical, I don't know. Maybe yes, maybe not. Maybe it could be part of their genetic activity, maybe, I don't know. But it could be cultural continuity as well.
But I wanted to ask you about the musician, trained musician who had, you didn't say what kind of neurological damage he had suffered, but he wasn't able to sing a tune unless he had the music in front of him, and then he had to... No, well, so what was that just him?
It has perfect
pitch, but without seeing it, he could not reproduce it.
No.
I didn't understand that.
No, I know you couldn't understand because I didn't explain.
Oh.
My point was just to illustrate that you can find this kind of problem in trained musicians.
With perfect pitch.
With perfect.
So when he could see the pitches, he could reproduce them perfectly, but otherwise he was a washout. Okay, then this relates to the question I actually had, which is actually, when I was a student, one of my fellow students played the saxophone. He was very good. He could improvise with anything, he could pick up any tune, but he could not pass his ear training course because he could not match pitches to sing. Even though there was nothing wrong with his ear, he didn't have the connection between the brain and the voice box. And so I just wanted to know how often you see that kind of thing, if it's documented.
You still know him?
I haven't seen him. You want to study them, right?
I've tried to find another pianist now for 5 years. I couldn't.
Sorry, I've forgotten his name.
But I've heard that many times in many different cities, so I just said, okay, if you have one, please send it. Because I think the problem is really related to relative pitch. He couldn't acquire it. But he didn't acquire it, and I think there is still a residual problem there. Yeah. Yes.
So I'd just like to follow up on that, because the most spectacular case was the guy who has absolute pitch, but
I know.
so when he does it, he can't imagine the notes for Happy Birthday. It seems to me like why can't he imagine a staff with notes on them and sing that way? Like one knows the song. There's something very, very strange about it.
We can discuss it later, but I agree. I would agree, but I think really his problem is that he has a very tight association between note names, subtension, note names, and the pitch, because I don't think he has really absolute pitch in possession. We have documented that, but it's not as good as in perception, of course. And so he has a very tight association with the note names and the correct pitch. But when he was reading, I mean, he never learned those songs correctly. That's the point, because nobody taught him. And I mean, and when he came to the lab saying, my girlfriend is telling me, and of course they are always musicians, they are the partner is musical too. She's telling me that, I'm like your cases. And he was completely unaware. So when he became aware, then he trained himself a lot. But it was so laborious. So, yes, so, yeah.
I'm mystified by this cultural myth about the average person not being able to carry a tune for lack of practice. I haven't encountered that myth ever, 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 ever. I think the default assumption for most people is that the average person will be able to carry a tune. And even if we have that assumption, but we also carry in our heads the cultural bias and we think that people are cultured to be musical, then we would assume that the average person has been exposed to enough music to carry. So where did you bump into this myth? Who espoused this myth?
And you know who wrote that? Stephen Pinker.
Oh, Stephen Pinker. Okay, now I get it.
You have to prove that it is wrong.
That myth doesn't exist?
Yeah.
Well, if he could point to someone who's so he espouses that myth. I'm sorry.
Oh, yeah, clearly.
Okay, now.
And if you ask, I mean, I don't know who you are here in this room, but I suppose that most of you are very interested by the topic, and so you are knowledgeable about it, etc. But if you ask to a university class, if they think that really most of people cannot play a tune, they will say, yes, they can't. This one, we can't. And they don't want to. I mean, if you ask them to sing in the lab, they say, oh, no, I can't. I can't.
Okay, I understand.
And we have to encourage them. And it's still the case now. People are just, replying to our kind of advertisement saying, I'm a good case for you. I can't sing.
Okay.
So the last time it was a professor of medicine whom I knew, and he was telling me, it's terrible. No, it's terrible. I mean, I was thrown away from choirs, and it was terrible. And I said, all right, come. Because this is the perfect case for us, well-educated, etc. And it was in tune.
So then on the whole, in your experience, you've encountered it in people who believe it of themselves. They're very insecure. They think that because they're lay people and they haven't been exposed to practice and training, they're probably not going to be able to carry a tune.
I mean, they are self-conscious.
Yeah.
So just a minority will be really on the tune, but the majority is not. And that's what I think Stephen Pinker was figuring out.
Okay.
That's what people believe, and that's what people
Isabelle, bizarrely, I have a music question rather than a neuroscience question.
Okay, I will give you.
Why is the minor scale so sad or so scary?
Well, it's an old question. It has been around for a very long time. So some people believe it is related to the harmonic series. But there is an argument there, because the minor intervals are really high in the harmonic series, and we are not sure we hear them. So it's not clear.
I was surprised. Did I get that right? That the 5 years old don't respond to the sadness
Well, half
of
of
the
them,
minor mode?
yeah, half of them don't really, in the way we tested them, I'm pretty sure they do earlier than that, but we tested them with classical musical zero. If we were using more display, I think it's earlier than that.
It would come earlier.
Yeah. I have tons.
Okay, I'll come with the next one.
Yeah, I'd throw a monkey wrench in the whole thing and say that much of our understanding and appreciation of music is culturally based.
Of course.
And
I
the minor scale is just a good example. I wouldn't be surprised if you did studies in from other cultures and played major minor scales, that they may have the exact opposite response of happy sad.
Right, but if you use dissonance, I mean, dissonance, I made, oh no, then I bet with you.
Well, it depends on your cultural idea of dissonance. We listen to Tibetan temple music. I listen to Tibetan temple music, and I'm ready to file for divorce. But he loves it. So that's a...
Yeah, well, I have tons of stories to tell. Okay, later on. I know you are musicians, and we have done tons of studies on dissonance. It depends, of course, on the definition of dissonance. But the way we manipulate dissonance is really something that is occurring as early as in the basilar membrane. It's the roughness that really you create really at the level of the ear. It goes up to the brain, and that's really something that is everywhere. I mean, because most of the sounds are consonants. My voice is consonant, everything is consonant. So I'm pretty sure you find that in both kind of cultures, but it's always very difficult to dissociate what is really culture and genetics. So it's only in cases like the ones I was presenting that we have a chance to identify the genes. Otherwise, it's too complicated. It's like for language. I mean, language is the same thing. I have a strong accent, I speak French, and other people speak two languages, and it's going to be very hard for us to learn, but we can learn, to understand. It's always the same kind of question. Whenever you have a question about music as a cultural product, ask yourself if you could ask the same question with language. And you see the response is always yes. And unless you think that language, really language is something that is not part of our, endowment, then it's another issue. Then we really have a fundamental disagreement.
It's just to finish up what I was mentioning there, when you brought up the point about dissonance consonants, I think the question that has to be asked is the point about pleasure. Someone mentioned pleasure in music, and whereas someone may find a consonant pleasurable, others may find dissonance pleasurable, and that's one of the very important features about tension and relaxation that is part of it.
But what I want to make here, then, in that context, is created that bond of tension, something that is highly enjoyable because of because of the musical context. But what I'm talking about is not about musical dissonance in the musical context. And of course, you can appreciate this kind of violation of what is, regular and sometimes broad. But that's not what I was interested in at all. And then I completely agree with that. I don't remember who asked. Okay.
With the biological basis to tone deafness, am I correct in assuming that that means that one cannot be trained if they are tone deaf?
Yeah, I'm afraid that is so, at the adult age. So now we are starting with 6 years old, and so we are screening them, and we're going to train them and see if we can, and the question is, of course, can they go as far as, their peers, that is as well as the other ones, or if they will be lagging behind. We don't know that. It's like dyslexia. You can train people to read, but they will never reach the level of people who have never had any problem with the reading. But that's a new question. We don't know yet.
Well, my question was because in high school I was in a play for musical theater, and I auditioned with this boy who sang the worst rendition of a song I've ever heard, completely tone deaf, was asked to sing a scale,
sang the same note the entire time, and it wasn't any of the right notes. And somehow he got into the play. And he trained the entire year, and he did progress a lot. He never got to be a very good singer, but he did get a lot better than he had been in the audition. And I was wondering if that would be more that he was trained on those specific songs, and he would have gotten better just in those, or...
That's hard to say, but in the same case for the case I was presenting, he trained himself for 2 years, and it was painful. He spent 5 hours a day doing just that. And yes, he does sing now, more or less correctly. But he will never reach the level that everyone would reach at the age of 5. Yes, okay, no, when you actually, okay. No, I'm sorry.
My turn?
Yes, yes.
Okay. I wonder, that's a question I often ask myself. Actually, there are 2 questions. The first one is more general. Like, is there something in the genes of Russian people such that the majority are very bases? And is there something in the genes in Latin, Spanish, or Italian people such that they're tenors? So that's one. So that's the first question. And
you need to go into research because we even don't know now.
Okay.
We are chromosomes and we know nothing about the case. So yeah, go into research.
And the second question is that I sing in choir and I'm a bass, and I wonder because my father is also a little bass, and my mother is a contralto. So.
And someone is Russian there?
So, but so is it also hereditary or still?
Well, you know, it's very hard again because it's that way. It runs in the family too. I mean, some have the money, you know, just because they have the money to start with. Same thing for music. I mean, if you are playing that kind of environment, of course you will get earlier and better. That's why it is interesting to work with the anomaly, because you can have the part of the genes and the environment that kind of keep apart.
Yes, I noticed that with one example, the fellow who was kind of inventing this piece, he used the same tune over and over again, I guess, when he was trying to sing. And what I noticed, though, was that he still had a sense of pitch discrimination. And I always assumed that people who are amusical would not have that, but he seemed to have it. And I guess my question is being amusical, is that something that obviously is different from being non-musical?
Well, you know, they are really there. It's like everything. It's not a question of core or non. There is a question of degree. So it's not that they don't pick anything. And we know, in fact, we know exactly what they do because you can measure that easily. What kind of pitch distance you can discriminate and you can account for. But I didn't go into that level. But it's not a question of they hear everything like a monotone. I mean, for some maybe it's close to. Unless they are very big pictures. But I'm sorry, I think I skipped your question many times, so I will take your question.
I had so many, but I wanted to
just
pick one.
And maybe it will be the last one?
Yeah, okay.
Because I can see people are leaving, it's fun too.
You've shown that some of your data was showing that while we are listening to music that could improve our capacities, or I don't know what was the
Mozart effect.
Exactly, but do you think that we should include music in our habits? Yeah. Like, there's a lot of students that are listening to music while they're studying. Should we include more music in our habits? Even do our exams while listening to music? I don't know.
I was really thinking of this, but in fact I should say, I mean, I think I have many musicians here. Do I? Okay. you're going to be very peaceful with what I'm going to say. What is really something that is repeatedly found is that musicians outperform non-musicians in tasks or cognitive tasks. Many. And if you take a class, it has been shown recently that if you train 6 years old on musical instruments and others, randomly determined groups, and another one is playing drama, for example, and another one in sports, or I don't remember exactly what it was. The group trained on musical instruments, on the keyboard, outperformed the others on IQ tests. And we find a correlation also, even if you take into account the income, all the other factors, they have a better performance. The more years they have been trained, the better the performance is in kind of academic tasks, like IQ tests, this kind of cognitive tasks. And this is really a recurrent finding. The way we account for it is that musicians are trained very early. Probably they were born with more resources, because when you have to attend the regular curriculum, and along with that you have to train yourself on an instrument, and you know how many hours can be. It's really demanding. Then maybe not everybody is ready or can take that much. So maybe these ones were born with a different, playing with more resources, with more potential to learn.
So you cannot do the same thing with an iPod or iPod.
Oh yeah, you can. Of course, you can work with an iPod.
Yeah.
Sure. It's a Rosie.
Dr. Peretz, you've been very generous with your time. Thank you very much.